Remember in section 1, we learned that frequency of a source determines the pitch. Frequency of the source depends on the source. It's subjective, objective quantity. But pitch was subjective to the listener. I mean, some listener can hear a different pitch than the other one. Young person, old person can hear different pitch possible. If there's a relative motion between source and the observer, even you can hear a different pitch. So which, remember, we represent this as f prime, and we calculated that in Doppler effect. A similar effect also can be observed in sound. Wave intensity determines how loud a sound is perceived by the ear. If you increase the intensity, wave intensity, how can you increase wave intensity? Two waves, as I said. So according to equation, power over 4 pi r squared, you can increase the volume, make the powerful source powerful, or you can move away or get closer to the source, so you can make change in wave intensity, and you can make change in wave intensity, you can make change in sound intensity. By the time, sometimes your book is going to say sound intensity, sometimes it will say wave intensity. They are representing the same thing. So then you can change the wave intensity by changing power, by changing the distance, and then you can make a sound louder or loud. You can decrease the loudness. So this how loud a sound is perceived by the ear is defined as perceived loudness, or relative intensity, or decibel level. These three words are representing how loud a sound is perceived by a human ear. Perceived loudness, relative intensity, and decibel level, and represented by beta. Beta is the symbol for relative intensity, symbol for decibel level, or symbol for perceived loudness. And as I said, as power and changes the wave intensity or sound intensity, so because by changing the power of the sound, you can increase the wave intensity, you can sound intensity. As power of sound increases, wave intensity at a certain point also increases. They are directly proportional. But loudness perceived by the ear also increases. Yeah, you can make the sound louder, heard by this ear. However, now here is something surprising, very surprising thing you are going to learn now. When you double the intensity, you don't hear the sound twice as loud. When you make a loudspeaker 5 watts, and then make it 10 watt, double the power, double the intensity, wave intensity, but loudness is not doubling, perceived by the ear is not doubling. So it is very good in some way for the teachers, because assume that in general students are talking in the classroom. One student, if produces a power of sound 5 watts, second student, if talks, it becomes 10 watts, so then power doubles. So wave intensity doubles, but loudness in my ear as a teacher is not doubling. That's why everybody can speak, and then it doesn't disturb me so much when number of students which are talking increases. So as sound A is twice as in the sound B. Yes, intensity is that because power is double, but sound A is not twice as loud as sound B. So it is less than twice. So reason for this is that sensation of the loudness in human ear is not directly proportional with the intensity. It is changing logarithmic. Did you hear about the logarithmic function before? Logarithm?
Yes, teacher. We did.
So logarithmic function is not directly changing, directly proportional. As for example, now you have a calculator most probably. So logarithm 5, now I will change, logarithm 5 is how much? I will check for it. Logarithm 5 is 0.7 almost, but logarithm 10 is not 1.4, it's not doubling. So 0.7 is logarithm 5, but logarithm 10 is 1. Normally, if it were directly proportional when I double, because I make 510. So result must change from 0.7 to 1.4. It's not like this. So it's not doubling. It's increasing, but not directly proportional. It's changing logarithmic. For example, logarithm 5 is 0.7. If I make logarithm 15, normally I should expect a normal function. If it's directly proportional, it must be 3 times 0.7, 2.1. But logarithm 15 is not 2.1. Logarithm 15 is 1.2, not 2.1. So reason is that somehow, I know, not maybe this is not something, it somehow is, God created the human ear not sensing the loudness directly proportional to sound intensity. Loudness is changing inside your ear by a logarithmic ratio. So that is loudness, relative intensity, yani beta, is not directly proportional to sound intensity. Relation between the loudness, relative intensity, or decibel level and sound intensity is logarithmic. Like every measuring scale, relative intensity also defined according to a standard. And standard is the softest sound. So softest sound is chosen as a standard for relative intensity. That's why softest sound is assumed to be a relative intensity which is equal to 0 decibel. Decibel is the unit of sound in loudness or relative intensity, or decibel level. Decibel level. So softest sound, remember what was the value of the softest sound? 10 to the power of negative 12 watt per minute square, which is the threshold of hearing at 1000 hertz. This sound is assumed to be having a relative intensity which is 0 decibel, because you start detecting the sound from that point on. Less than that you cannot detect. That's why logical. They gave this intensity of the sound as a relative intensity, 0 decibel. So other sounds will be compared with this one. Yeah, and other intensities will be compared with softest sound, and we are going to calculate the decibel level or relative intensity or loudness of a sound. So assume that a speaker is producing a sound by a power P, and then at this region it produces sound intensity or wave intensity I. So loudness detected by this ear can be written as relative intensity or decibel level, or loudness and so on at a certain point is defined as the logarithmic ratio. So it is logarithmic. It's going to be a logarithmic ratio, not normal ratio, what we know. Logarithmic ratio of the intensity of a given sound, to intensity of threshold of hearing. This threshold of hearing is represented by IO. That's why it's a specific number. IO is 10 to the power of negative 12. So we are going to divide relative intensity of any sound to threshold of hearing. So it's a ratio, but logarithmic ratio. It must be logarithmic ratio. So that ratio must be inside the logarithm. Then we are going to multiply by 10 to get the relative intensity or decibel level of any sound at any point. We can get this by this equation. So it's measured by a dimensionless unit called decibel. Dimensionless unit, because why dimensionless? Remember in chapter 1, section 1, we learned that radian was a unit which has no dimension, because we divide length, arc length divided by radius, length divided by length, they simplify. That's why radian has no dimension. The same thing, the relative intensity, beta, also has no dimension, because you divide sound intensity by sound intensity. So watt per meter square divided by watt per meter square. So they simplify. Still, it's a pure number. So how we added the unit radian to that number, we will add here also decibel as a unit for relative intensity or decibel level or loudness. What is relative intensity for sound at threshold of pain? We know that at threshold of hearing, sound in relative intensity is 0. What is relative intensity for threshold of hearing? It is 0 decibel. 0 decibel. But what about threshold of pain? Remember, threshold of pain has a sound intensity which is 1 watt per meter squared. And we know that softest sound has a sound intensity or wave intensity 10 to the power of negative 12 watt per meter squared. This is the softest sound. This is the loudest sound. So what is the relative intensity for the sound at threshold of pain? It's asking calculate beta for this. We know beta for the softest sound, it is equal to 0 decibel. So what is beta for this sound? Question is asking us. So we are going to use the equation for logarithm. So remember, logarithm is, the equation was like this. Beta is equal to 10 logarithm I over IO. So let's go with logarithm. You already learned in the 10th, in the 11th grade logarithm, you know about it. So I is 1. IO is 10 to the power of negative 12. I will get the logarithm of this. You can use your calculator or you can go with the logarithm. So I will not use calculator because you know about logarithm, I think. So this 10 to the power of negative 12 goes up to the numerator as 10 to the power of 12. This 12 in logarithm must be taken right here. 10 multiplied by 12. Logarithm 10 base 10 is 1. Answer is going to be 120 decibel. So relative intensity for threshold of pain is 120 decibel. This is also Mr. Exam question. They ask, you don't need to calculate, you'll learn this. So relative intensity for threshold of pain is 120 decibel. Yani loudness of a sound shouldn't be greater than that value for your health, for your ear health, not because it is the loudest sound, 120 decibel. What about the relative intensity for threshold of hearing? It is 0 decibel. So these two numbers are very important, okay? They can directly ask you in Mr. Exam. So which of the following is the relative intensity or decibel level for threshold of pain? It is 120 decibel. Which of the following is the relative intensity or decibel level for threshold of hearing? 0 decibel. By the time the original unit of the decibel level is given as Bell, named in the honor of Alexander Graham Bell, the inventor of telephone. But later this Bell is converted to decibel. So 1 decibel is equal to 0.1. And we are going to calculate from decibel level to the sound intensity as well. From sound intensity, decibel level is just you are going to write into the equation the value of I, and then you will get, what if the decibel level is given and they want you to calculate the sound intensity or wave intensity? Okay, decibel level is now, again, I will use the same equation. Beta is equal to 10 logarithm I over IO. This is the equation which I'm going to use. In this equation, beta is given as, decibel level is given as 30. Write 30 instead of beta is equal to 10 logarithm I over IO is 10 to the power of negative 12. We know it. It is constant number, threshold of hearing, softest sound, 10 to the power of negative 12 watt per meter square. So we will calculate I. First, divide by 10, simplify 10, simplify zeros. So you will get it as 3 is equal to logarithm I over 10 to the power of negative 12. So how can you continue logarithm? Base normally 10. Is it in here? If base is 10, you should say that this I over 10 to the power of negative 12 is equal to 10 to the power of 3. Cross product. So I is going to be 10 to the power of negative 12 multiplied by 10 to the power of 3, which is 10 to the power of negative 12 plus 3, which is equal to 10 to the power of negative 9 watt per meter squared. So you can get the sound intensity by, if you are good at logarithm, so you can get on your own. But general students are forgetting about the logarithm. That's why I am going to give a hack for you. Hack is short way. So how to convert. So this is what the way using the logarithm. But if you don't remember the logarithm, so you can use this hack. What is this hack? How is this? Now you will see that. Okay, hack is this one. Normally we calculated it as the logarithm by using logarithmic operations. How you learn in maths as 10 to the power of -9. Or if you don't know logarithm, just put the beta in here. So I is going to be 10 to the power of, in the bracket, but it is the power exponent, beta minus 120 divided by 10. But beta minus 120 must be in bracket because you are going to divide both of them by 10. Let's do it. Beta is how much? 30. Minus 120 is constant, which is also known as loudness, the loudest sound, divided by 10. So 10 to the power of 30 minus 120, it is 90, negative 90, is it? Negative 90. Divided by 10, which becomes 10 to the power of -9 watt per meter squared. So if you are good at logarithm, go that way. But if you don't remember the logarithm, this hack will help you to convert decibel level to corresponding sound intensity or wave intensity. Okay, exercise 2. If the decibel level is 60 decibel, calculate the sound intensity I. Again, let's use the hack for this one. I is equal to 10. So in bracket, beta is given as 60. 60 minus 120 divided by 10. Go 10. 60 divided minus 120, negative 60 divided by 10. Simplify zeros. So it's going to be 10 to the power of -6 watt per meter squared is the corresponding sound intensity. And ministry question 2014 and 15, they asked this ministry exam question. When the decibel level, yani beta, relative intensity of a traffic in a street goes from 30 decibel to 60 decibel. Yani it's increasing, as you see, loudness. So this is initially decibel level. This is final decibel level. How much greater the intensity of the noise? Intensity of the noise means sound intensity or noise intensity. It's asking you, I increases by what factor? I increases by what factor? Which means you are going to find I final over I initial in here. What is the ratio? I final over I initial. How much greater means this? How much greater the intensity of the noise when it goes from 30 decibel to 60 decibel? What is I final over I initial? In fact, we calculated I final and I initial. We know 30 decibel has a sound intensity 10 to the power -9. We just calculated in here. So I final over I initial. First, you should calculate what I initial is. So corresponding I for beta initial 630, it is 10 to the power of -9. Then you should calculate what is the I for 60 decibel, which is just we calculated 10 to the power of -6. After that, you should divide them. 10 to the power of -6 is for decibel sound intensity for 60 decibel. 10 to the power of -9 is the sound intensity for 30 decibel. So then you divide them to compare how much greater the intensity of the noise. So we are going to get this like 10 to the power of negative 6 plus 9, because this negative 9 goes above as plus 9, it's going to be 10 to the power of 10 to the power of 3. Yani 1,000 times. 1,000 times greater. How much greater is the intensity of the noise? 1,000 times greater is the intensity of the noise. I'm going to show you one more hack for this. This is so easy. So how much greater the intensity of noise? It's asking you I final over I initial. Beta final is how much? It is 30. Pardon, not 30. It is 60. From 30 decibel to 60 decibel. Initial is 30 decibel. Because it's going from 30 to 60. Means initial is 30, final is 60. If you need to know I final over I initial, yes, this question is asking about that. How much greater? Means final divided by initial sound intensity. Write 10 and 10. After that, get 6 first letter. I mean, what is this in mathematics called? This 6 here in here as power. This 3 in here as a power. 10 to the power of 6 divided by 10 to the power of 3 is how much? 10 to the power of 6 minus 3, yani 10 to the power of 3, yani 1,000. One more question, conceptual question. This is also a good question, also ministry exam question. Federal regulations require that no office or factory worker can be exposed to a noise level. Noise level is representing relative intensity in here that average about 90 decibel for 8 hours. Yani a worker in the factory can get a loudness which is 90 decibel. Yani factory shouldn't produce a loud noise level greater than that for the health of these workers in 8 hours. Thus, a factory that currently averages 100 decibel. So this is dangerous. So he should get this 100 decibel to 10 decibel. So by 10 decibel, so then again he should get this 100 decibel to 90. So currently average is in this factory is 100 decibel, must be reduced its noise level by 10, so then final is going to be 90 again. So right now it's 100 watt. Assuming that each pieces of machinery produces the same amount of noises. And there are machines, all are identical. Same amount of noise means they are identical. They are making the sound. They are making sound. They are making that factor noiser. What percentage of the equipment must be removed or must be switched off? So you should switch off some machines to decrease the noise level. So now, initially, what is the initially currently the decibel level? 100. So this is initial one, initially 100 decibel. But we should decrease this decibel level to 90 because 90 is safe for workers. So I am going to decrease this decibel level from 100 to 90 decibel. But to do that, I have to switch off some machines. So question is asking, what percentage must be switched? Okay, what makes the sound in here? The machines are making the sound. Remember, we said that sound intensity is proportional to power. As power increases, sound intensity also proportionally increases. Remember the equation I is equal to power divided by 4 pi r squared. Yeah, if you double the machine, if you use 2 machines, sound intensity doubles. If you use 3 machines, sound intensity triples, or 4 machines increase by 4. Yani sound intensity I is directly proportional to the number of machines. In fact, if you find the ratio of sound intensity final to initial, you are in fact calculating the ratio of the number of machines initially, finally running and initially running. I mean this, and say that it is number of machines. Number of machines. So if you find the ratio between the sound intensity final divided by sound intensity initial, you are going to calculate also number of machines finally running, number of machines initially running. That ratio can also be calculated because we know that sound intensity is proportional to number of machines. Let's get this I final over I initial in this case. So we can use the hack. Hack is very easy. I final or initial 10, you write 10 and 10. This is 9. Forget about the 0. Just remove 1 zeros. So it is 9. This is 10. 10 to the power of 9 divided by 10 to the power of 10, which means 1 over 10. So which means if initially there are 10 machines are running, finally one must be running. How many of them must be removed? How many of them must be switched off? Of course 9. If initially 10 are running, initially 10 running machines, finally running machines. So if initially 10 are running, the final 1 is running, which means 9 must be removed. But the question is asking percentage. So not asking from 10 how many must be removed. What does percentage mean? You are going to do the things according to 100, is it? From 100 machines, how much must be removed? So you should change this rational number to percentage. How? It's possible you can multiply the numerator and denominator with the same number. Ratio doesn't change mathematically. So numerator will be 10, denominator will be 100. So I convert it to a percentage. If initially 100 machines are running, finally 10 must be running, is it? So how many must be removed in this case? So if initially 100 machines are running, finally 10 machines are running, so then remote machine must be 90. Yeah, 90% of the machinery must be remote or switched off, 90% of them.